Hi everyone, this is Kiran. I'm from Aeronautical branch and my rule number is 2095-1A21B5. Now I'm going to tell about inverse Laplace transform employing first shifting theorem. A Laplace transform which is a constant multiplied by a function as an inverse of the constant multiplied by the inverse of the function. First shift theorem L minus 1 f of s minus a equal to at f of t, where f of t is the inverse transform of f of s. If f of t is a causal function, then the Laplace transform of f of t is written L of f of t and defined by L of f of t equal to z if infinity 0 e minus st f of t et. Clearly, once the integral is performed and the limits substituted, the resulting expression will involve the s parameter alone, since the dependence upon t is removed in the integration process. This resulting expression in s is denoted by f of s. Its precise form is dependent upon the form taken by f of t. Definition of an inverse Laplace transform. A function of t whose Laplace transform is f of s is called the inverse Laplace transform of f of s and may be denoted by the symbol L minus 1 of f of s. Note: two functions which coincide for t greater than 0 will have the same Laplace transform. So we can determine L minus 1 f of s only for positive values of t. Inverse Laplace transforms are linear. Proof is L minus 1 of a into f of s plus b into g of s is a function of f whose Laplace transform is a into f of s plus b into g of s by the linearity of Laplace transforms. Such a function is a into L minus 1 f of s plus b into L minus 1 g of s. We consider problems where the Laplace transforms are rational functions of s. Partial fractions will be used, although the s of a Laplace transform is an arbitrary positive number. We may temporarily ignore that in order to complete the partial fractions. The inverse Laplace transform could certainly be obtained by using partial fractions, but also it could be obtained from the convolution theorem. We should also note that the phrase inverse Laplace transform can refer to either the inverse transformed function f or to the process of computing f from f. Although the inverse Laplace transform can be examined at a deeper mathematical level, we shall be content with this simple-minded approach to finding inverse Laplace transforms by using the table of Laplace transforms. However, even this approach is not always straightforward, and considerable algebraic manipulation is often required before an inverse Laplace transform can be found. Next, we consider two to standard rearrangements which often occur. Thank you.